Okay, hello and welcome all. Again, yet another talk on disability studies, but this time it's not going to be just a talk. It's going to be an interview with Professor Madhusudan Rao, IIT Delhi. He's a professor of mechanical engineering. Now he also heads design engineering department in IIT Delhi. Professor Rao has pioneered many things, many technologies in the field of assistive technology. I remember at least two, which is one, a braille computer, most affordable one, and second, an ultrasound mobility cane for visually impaired people. Both coming from the third world and so on. Before asking him about all these things and much more, let me say a few things about what is technology and assistive technology in particular, and why that should matter for a course on disability studies. Well, broadly, technologies, people say it's a kind of, some people associate technology with machine and tool. But much more broadly, technology is a network of systems consisting of people, learning environments, operating systems, cultures, powers, the ways one does production, several science systems such as watching TV, consuming video, photography, and so on. Then technology can also mean how one network and processes or even thoughts that shape self, maybe culture, maybe a whole system altogether. So it's not, technology is not just a machine, it's much more. In that way, there is a special field, assistive technology. I don't want to define what it is, but I can say pretty much that assistive technology comes in myriad shapes. It can help people to breathe, think, learn, converse, even live. Okay, so it is a very specialized form of caring, accessing information, learning, and living in society. With that note, let me start our conversation with Professor Rao. Professor Rao, you have been in assistive technology field for a long time, but before getting into that, can you tell us briefly about yourself, your training as an engineer, and how you happened to get into assistive technology?
Okay, so I am primarily trained as a mechanical engineer, and I joined IIT Delhi Mechanical Engineering Department about 22 years back after my PhD in mechanical engineering. And I also work on areas which actually kind of cross section of mechanical engineering and information technology. The way it happened is one of our student groups were working on assistive technologies for the blind in the Department of Computer Science. And in that particular project, they needed somebody with mechanical engineering background. And they approached me if I can probably help with that project. And that's how our 12-year journey an assistive technology started. And now I think for last 12 years, we have been working on multiple assistive technologies for the visual impaired. And we have now at least 4 technologies we are able to take it to market. And we have now close to about 100,000 users of these products developed, which came from the lab. And I think it was more of an opportunity for us to apply a technology for, I would say, a social good. That's what probably brought us to assistive technology.
Wonderful. In the last 12 years, do you see your work in assistive technology in any way shaping your thought about your mother discipline, say mechanical engineering, how you think about your discipline, how you teach your discipline? Has it in some way influenced your work with assistive technology?
Yeah, sure. It's not only mechanical engineering, but what we see worldwide is that many interesting things are actually happening where more than one disciplines are actually intersecting with each other. So as I said, a lot of assistive technology is to do with information technology with design, information technology with mechanical engineering. And I think this coming together of multiple disciplines to address real grand challenges facing our society has been a wonderful experience for us. Sometimes individual disciplines probably can't address a problem, but I think when more than one disciplines and people with different expertise come together, we have seen that more impact is being made and many more solutions are coming out.
Sir, can you give us some examples so that we actually, many of our audience can be engineers, young engineers. So if you give us some specific examples, we'll be grateful.
Yeah, okay. So if you know, we have been working in 2 major areas of assistive technology. One is to address mobility challenges, and second is educational challenges. So our initial work in assistive technology lab at IIT Delhi was more in looking at mobility related issues. Actually, we started with education, but then we realized very soon that mobility is a precursor to education, and we gave priority to mobility. And first few technologies which we took up was how do you address the outdoor mobility of the people with visual impairment without any sighted assistance. So this actually led to a product which is called as a smart cane. And what smart cane does is it helps visually challenged person to basically negotiate unwanted collisions and obstacles, and to be independent in terms of mobility without any sighted assistance. Usually the white cane, which is commonly used by the visually challenged people, is helpful to address obstacles up to knee height, but knee to head obstacles cannot be detected by the white cane.
Oh, definitely. I have innumerable situations. Walked into a truck actually. Usually the rear side of the truck is a usual culprit.
Yeah.
Because one cannot detect it, echolocation, call it whatever. But a visually impaired person can run into it. In fact, ram into it.
Yeah. So standing truck is a very big, I think, issue in particularly countries such as ours.
Correct.
And also
and projecting windows.
Please go ahead.
Yeah, projecting windows, window projections. Yeah.
Projecting windows, then projecting air conditioners, tree branches, then hoardings which are put up on the roadside. So we have found a large number of people complaining about unwanted collisions with these obstacles, and that's how the product journey of SmartCane, which started as an undergraduate student project in computer science, but I think soon we also had a mechanical engineering students joining this particular project. And what we actually also found why multiple disciplines is needed is when students actually took their computer science students who did this project took their product to people, most of the problems which were pointed out were not related to computer science, but they were more of a mechanical engineering. So
Such as what,
then
sir? Such as what? Such as
yeah, for example, people said that weight of the product is very high. In other words, it's very heavy. And people said that it actually, when using for longer hours, it kind of pains their palms because of an imbalance.
Yes.
And they said it requires ergonomic considerations to be taken care. People also gave inputs about materials, and then we thought that many of these issues can be addressed by mechanical engineers, and that's how the teams came together to address this problem.
Did it also involve engineers from maybe in charge of sound engineering, biotechnology, because all these ultrasound devices interact with the human body in a peculiar way? Did it also involve environmental engineers? I'm just thinking like a typical humanities person. My question also may be wrong, so maybe you can correct me and also address this question.
Yeah, but what we felt is that it started as a computer science project, and then the mechanical engineering team was brought in. Our subsequent problems were less with other branches of engineering, but at some stage we felt that design is a very important component in all product design. So we had industrial design people working with us, and when we addressed some of the design and engineering problem, we also felt that social sciences is a very important component in terms of understanding the people and the anthropology and the kind of people who would be using their daily lifestyles, their habits, and capturing that became a very important. And also even understanding the social stigmas which are associated in using such technologies clearly came out. Then we also had a consultation with faculty from social sciences, and we had to also work with people who train people in mobility, like orientation and mobility experts, social workers. So it became a big interdisciplinary team with almost like 8 to 10 different specializations, and that is probably was also one of the reasons for success of this product.
Wonderful. At this point, maybe it is worth mentioning that assistive technology as a field is quite a diverse field in itself. I mean, Professor Rao was highlighting upon the idea of interdisciplinarity and multidisciplinarity. Not just that, it is also has a diverse catchment area. For example, IT industry may cater to people with mobility and dexterity problem, or that's one modality. Say somebody does not have use for limbs or lesser use for limbs and hands and legs and so on, or a deafness or hearing loss, or blindness or low vision. Maybe perceptual and cognitive limitation, say somebody has problem with memory, short-term memory and so on. And even speech loss. One is not able to communicate well due to a vocal cord condition because of an illness. Say Parkinsonism can lead to that. So all these human conditions, I've said 5 kinds of condition, they will require different kinds of imagination. And look at the possibilities of diversity of interdisciplinary engagement such an exercise can do. Professor Rao, you also said you have come with 4 products. Can you also mention about some others?
Yeah. So one of the products which we worked on is basically for visually challenged people to use the public bus independently. That is a second mobility device. We have now deployed some of these things in Delhi buses, and we are doing a large pilot. The third product.
One second, sir. What is using buses independently? What does that mean? Can you explain to the audience?
Yeah. So generally what happens is if a visually challenged person has to use the public bus independently, there are 2 problems which are associated. One is to know what is the number
of the bus
number which has come.
Yeah.
That is the first one. And a bigger problem is to know where the entrance to the bus is. Because in countries such as ours, buses do not stop at a particular position or a bay. They may be standing a few meters away from the bus stand, or maybe a few meters even before the bus stand. So one of the biggest problem which a visually challenged user faces is to know where the bus entrance is. So when they know that there is some bus which has come through audio perception, they start moving towards the bus to find the basically entrance to the bus. And in this particular process, there could be a more serious collisions, etc.
Correct.
So our innovation basically addresses these 2 problems. One is to know what is the bus which has come in terms of number, and second is where the entrance to the bus is. So in order to do that, we put a small unit at the entrance of the bus with a speaker, and there is a handheld device which user uses. So this handheld device can be used to query the bus which are in the vicinity.
Yes.
And it reads out all the buses which are within a certain range. The moment user selects one of the bus numbers which he or she has to board, then the audio at the bus entrance starts speaking the same number in a louder way.
Okay.
So that you use the audio clue to know where
navigate
the bus entrance is,
yes.
And then you can board it independently. So this is a second product which we worked. The third product was also to make diagrams, particularly in textbooks, etc., accessible to the visually challenged. So one of the big problems which we faced in India particularly is that there are many textbooks of state governments and central government and NCERT where the text portion is accessible, but the diagrams are not accessible. Because when they actually convert the book into an accessible format, they delete all the figures, only convert the text portion into braille, and students are left to study only the text portion of the textbook without reading the diagrams. And this actually is a serious problem, particularly in terms of learning, particularly when you go for higher classes and subjects such as science, mathematics, economics. It becomes extremely difficult to learn the concept without pictures. So what we do now is that we also have converted quite a few NCERT textbooks into an accessible format. And in order to do that, we use basically a plastic sheet and emboss the diagrams onto it using a thermoforming process, and that gives them a tactile feel of the diagrams. Through tactile perceptions, they are able to basically get the diagrams. And probably now they also have some of the books which are accessible both in terms of text and the diagrams. So this is another project which we have done, and we are still doing. We are converting large number of books and many of the materials with diagrams in the form of these books. And here also we have reached out to a very large number of audience already, a few tens of thousands. People are using these books.
Actually, thermoforming is nothing but a kind of photocopying of braille. Hard paper's impression gets carried over to the plastic sheet. Is that right, sir?
That is true. So what you do in thermoforming is you heat the plastic sheet and press onto a master. And so whatever is the impression of the master is transferred onto a plastic sheet.
And so, and you replicate the process for thousands of copies.
Yeah, and you can do any number of copies once you have a master. So, but preparation of a master is a precursor. And in order to do these masters, we put technology to work. Like we use more contemporary technologies like 3D printing, etc., to make these masters quickly. And then using the 3D printed molds and masters, we produce the thermoformed tactile diagrams, which are basically accessible.
And to test these copies, you distribute it to school children so that they give you feedback about relief points and how they are able to access a particular information. Something is shaded, something needs more tactile relief and so on. Do you get such feedbacks to develop the system?
We do take continuous feedback, not only from the students, but we also work with large number of special educators.
Okay.
So we have and one of the good things which has happened in 12 years of working in assistive technology is that we are able to build a relationship with more than 50 organizations and a few hundreds of experts in these areas like special educators and orientation and mobility experts who actually help us, or you can say that they are part of our team.
Correct.
And we co-create solutions working with them. So you mentioned about interdisciplinarity. So what we found is in assistive technology space, user and special educators are very integral part of a team. Unlike other technologies where someone designs and someone else uses, what we found that in assistive technologies, bringing the user and the other stakeholders very early in the innovation process is extremely important.
That is entire product and process, they are co-created.
They are our co-creators. Right.
Fantastic. So that makes me ask you about human technology interface, HTI. This is a term I picked it up from the net because it is this protocol that technologists talk about when it comes to user ends, how they want to design architecture and all that. How are you able to connect with that kind of mainstream vocabulary when it comes to AT, your work with AT, sir?
Yeah, if you actually look at almost all major assistive technologies require this human machine interface or human computer interface, which is a very integral part of it. And if you have actually looked at the assistive technologies which have come up in last 10 years, many of them also use mobiles and computers extensively. So the human-computer interface becomes an extremely important component in all our design of assistive technologies. And now it has become a separate area. For example, human-computer interaction is a big area in computer science and design. And the large number of experts are now available, and are also large number of people who are being trained who can do human computer interface. And so that interface is an extremely important, and many times this solutions to these actually comes from the users themselves. In other words, like one of our approaches has been to do lot of iteration of the product with the users, who actually kind of ratify our approach human machine interface, whether it's actually working or not.
Okay. So in some sense, did you also find that in AT world, assistive technologies, people who are users are more intimate with AT than users of mainstream technologies? Do you find that anytime? Because I ask this question because I am a AT user. I use screen readers and so on.
Yeah.
If 3 or 4 of us meet, we debate about which speech is good, whether JAWS synthesizer speaks better on NVDA, and we end up fighting actually, because we are intimately connected with the voice that gives us access to learning and living. Do you find, in some sense, my question is, you have done a lot of field work with AT users and you have done a lot of interactions with them. Do you find that this interface, intimacy is one of them? I'm sure there are many others that users of AT related to AT in a very peculiar way. Do you find that?
Yeah, but I think our interaction for now almost a decade also shows that you mentioned about two terms, technology and assistive technology.
Yes.
Ideal situation is when we actually don't want to differentiate ideally. In fact, if you ask me what is the assistive technology which people would ideally want, my answer would be none. Because ideally what they want is whatever technology which is accessible to the sighted user or the normal user, ideally they would like to use the same thing provided it is made accessible, rather than developing a separate technology exclusively with a particular impairment. That is one of them. So in other words, what an ideal user prefers is a universal design. Like if I'm designing a product which is actually meant for, let's say, a sighted user, it should ideally work for visually challenged user also, provided you add few additional controls. For example, one of the persons actually came and said, every time I go to buy my vegetables, weighing machine is not accessible. It doesn't speak out how much weight is being, like what is the weight which is being weighed, etc. They want that weighing machine should be universally designed so that you can also have a small interface where it can actually read out the weight or speak out the weight, etc. But I think there are some cases where assistive technologies are inevitable. Like you said about screen readers and braille computers. These, like for example, braille is very specific to a particular type of a disability. But I think one of the approaches which ideally we would like to take is to make the technology products which are available as much as accessible to visually challenged. Wherever it is not possible, then the assistive technology is the only solution to do.
Yes, that makes me think about millions of websites. Some of them are accessible, straight as they are introduced, but many of them you have to fight, beg, plead, and so on to make them accessible. And some of these websites are very basic because they help you do the shopping, book your air tickets or train tickets or even bus tickets, or even pay your tax, access information about health, and so on. Many are not accessible. I heard about a software called Bobby, BOBBY 3.0. It 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 seems it can help designers of websites to basically run their websites through and check for accessibility, self-check mode. There are some universally, universal design. Well, I use mobile phones that are accessible out of the box, but many others are not. So you're right about saying in an ideal world, assistive technology as a field doesn't have to exist, but since it is not, it has come in the picture. That makes me ask you about your next product, Braille computer. Can you say a little more, sir?
Yeah. So before I go to Braille computer, I would like to just mention about what you said about particularly the websites and the mobile applications. So we are also doing now a major research in those aspects.
I see.
So one of the things, for example, if you take the mobile phone has a lot of accessibility features. It basically helps you to use it in almost the same way a sighted user would use. But I also agree that there are a lot of limitations, and as you said, you mentioned about a particular software, but if designers of the software and these mobile interfaces and the website designers can be trained, there is a much more, I would say, wonderful and value added things can happen. Just to give an example, so whenever an interface is designed like either a website or a mobile, three things are very important. One is utility, second is usability, and third is user experience. So what we found is utility is somehow taken care, but usability and user experience is something which is seriously lacking in many of the mobile applications, etc. Just to give an example, suppose if I want to buy a product from one of the, let's say, e-commerce websites, let's say if I want to order a book or let's say any of the products from the e-commerce site, sometimes for a visually challenged users, the experience is not the same. Somehow they are able to order it, but I think they have to go through a lot of hassles and mistakes before they are able to accomplish. So I think that is where we are actually trying to look at how to prepare guidelines to improve the usability and user experience apart from the utility aspect, which is somehow taken care. That is an important component, missing link, which we are trying to address. The second thing is coming to the Braille computer. We call it as a dot book. It's a refreshable Braille display. It's like any other laptop, except that instead of a visual display, we have a Braille display. You can display up to 40 characters. This particular dot book can be used to read, write, browse, chat, listen, edit, just like any computer or a laptop is used for multiple applications. And in other words, this is like a one single device which can be helpful for visually challenged user to access any digital content, whether it's a computer or a Kindle or a mobile or internet, one can do. A very good example is when we were actually training a group of students on the dot book. in one of the sessions. This student actually went on to social media and posted within a few minutes his experience about this particular book.
From the same
We
device.
didn't even come to know that this person is actually using a social media and actually trying to write about this particular device, which we came to know much later.
Well, see, they say accessibility, it's good that you use the word usability because there are different kinds of vocabulary that terminologies that do the rounds. One is accessibility. A product can be accessible in a vague sense. That is, I can somehow get through it. I can, in some sense, it will help me to log into the system, but not log out. It's kind of a chakravyuha. You got into it. But usability is that which you make it your own. You connect to it. You fully use it. You become a full customer in that sense. And there is one more term doing the rounds, accommodation, but that again comes to how a system can bring in a customer or a user, say a university, a college, how it can accommodate people with different requirements, including disabilities. So, but did Braille, did dot book get you some experiences that you did not see before by way of working with people with visual impairments? What is your human interface learning in that area, sir?
Yeah. So one thing which we did is we not only built the hardware, but we also looked at what are the user requirements in terms of the kind of interfaces. So we also work for almost now 3 years on the software aspect of it. So the software aspect actually captures a lot of things which users would ideally want. Like, for example, let's say if you want to go and want to know what are the, let's say, headlines of today's news from any of the websites of a newspaper. So what happens is you can probably go and open the website, but before you are able to reach out to the headlines, you would have clicked maybe some 15 tabs before you reach to the actual news. But I think the Braille computers and these help us to build the interfaces which are specifically suitable for the visually challenged users. So in other words, if I'm using a Braille computer or a refreshable Braille to access a website, I'll get a much better experience than using a typical screen reader because screen reader goes very sequentially. And it has to do because it has to go through the same HTML format in which the
From top to bottom.
Yeah, top to bottom.
Yeah.
But I think in the Braille, you can actually, your interfaces need not be same as any other interfaces. And I think that actually kind of helps you to improve your user experience in a much better way, which is there. And other thing which from the user point of view, many users wanted text to Braille rather than text to speech. I would say text to speech and text to Braille both are required. But text to speech was easily available for many students, but that actually did not contribute much to the learning because text to speech is still a passive way of learning. For example, a student who is actually able to go through a story would read a story through audio output, but probably may never learn the spellings because it's only a reading, but there is no writing which is involved. So Braille, text to Braille actually gives a much bigger advantage for an active learning. And we found that many people feel that these devices will help in terms of their higher education and employment opportunities.
Well said, sir. Actually, you echoed my own sentiment with Braille, because once it's like, I'll make a comparison. You read a story, you make somebody read a story, and then you have it on print and take it privately and read.
Really.
It becomes much intimate. Maybe you pause on a sentence and imagine
Exactly.
situations.
Back
So
and forth.
yeah, back and forth, and and even the format of the Braille along with the story gets registered in the mind.
Oh, okay.
It kinds of an animation, just as you will remember a graph on a printed page when imagining a mathematical problem, because it automatically comes to your mind. A musician would, for a musician, when playing, a notation on a paper may also magically reappear in the head. I would say reading Braille is as multi-sensory as that. Along with the audio rendition, sometimes Braille animates in your head.
Okay.
When I think about the letter L, I automatically associated that with a 3-letter word instead of the other thing. Having said that, sir, I want to ask you something, because lot of your counterparts and colleagues around the globe are also into this larger debate, universal design or assistive technology, what is the role of technology and so on. But is there something that differentiates AT embedded in advanced world as opposed to third world or developing society like ours? What is the difference? You are working for a third world,
Yeah.
not England.
Difference is very huge. Particularly what happened is many of the advanced countries have realized the power of assistive technology very early. And also made a lot of investments in terms of development of these technologies and also taking it to people. So assistive technology is one area where even the most advanced countries give a kind of a subsidy, or in terms of like either through distribution of these devices to the people free of cost or at a subsidy, so that it reaches the people. Because if you see, assistive technologies are not market driven, even in countries which are very advanced. So somewhere the role of government comes. But when it comes to countries such as India and almost 90% of the world, assistive technologies have still not made much of the penetration. So technology development work started very late. And second very important thing which we found through our own experiences and research is that products which are actually designed sometimes for the advanced countries, they don't work when it comes to countries such as India, because environmental conditions and the regulations, as well as the kind of I would say conditions under which these products have to be used is very different. Because we found that some of the mobility devices which, when we actually bought from the advanced countries and gave it to people, people came up with large number of problems because they don't work in countries such as India, and that is why we had to do this complete co-creation with the users, and then take it to the people, kind of a thing.
So can I give an example, personal example? I used to use a mobility cane, folding mobility cane in England. At the bottom of the cane, the tip is in the form of a roller. It rolls.
Roller,
Yeah. Why roller? Because roads in that part of the world is absolutely predictable and flat.
Exactly. Yeah.
And the pavements are just a 1 inch, they call it crib, 1 inch above the road. So when instead of tapping my cane, all I have to do is roll from left to right, make an arc movement.
Yeah.
Where when the road changes, the nature of the road changes, say I get into a, I'm about to hit a platform, the roller gently slides up and I know that I'm going to hit a new pavement.
Yeah.
But that's not how it works in our country. I mean, there are no pavements in the first place.
Yeah.
So you need a tapping cane,
Yeah,
not
you
a
need
roller.
a tapping cane.
Yeah.
And I think the other products also, like the smart cane, the kind of obstacles which you need to negotiate
Here is different.
generally are not found in countries such as which have more regulations, etc. And same with the bus identification
Correct.
system.
Correct.
Buses always stop at a bay. You don't need actually a bus identification
Correct.
system.
Correct.
In a country such as this. So that's why we say when it comes to assistive technologies, science is global, but technology is still local.
I like that, sir. I'm going to say this everywhere.
Yeah.
Well, that I think in talking about the differences between the advanced world and the developing societies, cost effectiveness does matter. I'm tempted to ask this question. When India sent this Mars mission, lots of newspaper columns carried some references about the idea of frugal engineering, low cost materials, and we were able to achieve a huge exercise like Mars mission with less cost than many advanced world. So what is the conversation between frugal engineering and your work with assistive technology? You are an engineer with feet in both the worlds. Can you say a little more?
Yeah, I think what we are seeing is a lot of frugal engineering is happening in assistive technology, and that's why it's able to reach. And we also have a new generation of students and innovators who want to connect with the real world and coming up with a lot of innovations in assistive technology, which either are reaching the market or have a potential to reach market. Other thing which is also important is that the technology is now available at a very affordable cost. Earlier, there was a time when electronics used to be very, very expensive. But if you look at electronics, it's available at a very, very affordable cost. And hence, if we can actually make use of the frugal engineering skills, it can reach. For example, when we made Smart Cane, we could actually do it at a price which is like almost 1/20th of the price of a similar device which was available globally. And of course, with many more improved modifications. So technology is definitely changing. But having said that, still, in order to reach assistive technology to people, affordability is one aspect which we need to address. There are two more which are very important. One is access and awareness is becoming a much bigger bottleneck. Like I can tell you, I was actually attending a workshop where a lot of school teachers were discussing about how to make mathematics accessible to the students. And the kind of problems which they brought, we knew that solutions are available, but only thing is they are not aware that such solutions are available. So somewhere we need to address the awareness. And second is how to make these assistive technologies easily reach the people through multiple schemes and business models is second thing which we have to figure out. So if we can crack this affordability, access and awareness and I think we can really do wonders in countries such as ours in penetrating assistive technologies.
So true, sir. There is, people talk about digital divide in the electronic world, where you talk about people who have access to information, information rich and information poor. Sometimes I read a nice article by an academic, Vandana Chowdhury. She calls it visual inequity, meaning, well, this information exists, but if you are in part of the world where it is not, that information is not circulated, say in suburban India, or some information reaches me in an aggressive visual format, then I will not even know about its existence. I may just ignore it or just let it pass.
Yeah, I agree with you that this divide has kind of increased also. The moment the digital technologies have come, the pictorial content has increased tremendously. So the explosion in pictorial content has also made this divide this gap, which is much more stronger. Unless we have a good assistive technologies to access the pictorial content, which still the world doesn't have in a big way, this divide will continue to exist.
Yes, that is where the relevance of your dot book comes into existence. Wonderful, sir. What is the future that you are looking for in terms of your personal involvement with AT and in also the larger picture?
Yeah, I think our journey with AT for last 10, 12 years has been both professionally and personally very satisfying. And I think we'll definitely be continuing this journey into future. And we know that there is a large number of unmet needs which needs to be addressed. At the same time, we are very happy that there are large number of students and young generation who are coming forward to basically work in the space of assistive technologies. So, in other words, we basically look at huge opportunity, and there are two more opportunities which are very interesting. Is as we are developing these products, though they are being developed for countries such as India, but they are also finding basically market in global world. We said products which are developed in advanced countries may not work here, but the reverse is not true. so, so if as we are developing affordable technologies, they are not only being sold in other countries such as India, but they are also able to reach countries such as UK and USA, where there is a huge market for these products. That is one. And second, particularly which is relevant to your course, is that as we are trying to use technology to solve these problems, it is actually throwing away new research challenges, particularly in terms of understanding disability and the social sciences aspects. And we are also looking at how do we address these challenges. For example, when we were actually working on these tactile books and tactile diagrams, one of the challenges which we always had to address is how is visual route to learning is different from tactile route to learning, particularly from the how does the brain perceive tactile information versus visual information. And this has actually thrown up new research and PhD problems for our students.
And also this is cultural also. Yes.
So we started with very frugal engineering of technology to work, but we are also ending up with much more basic
fundamental questions. Yes.
So always we say convert first to do a research and convert research output into products and solutions. But assistive technology has done a reverse for us. We started with application, and application is throwing away new research challenges.
Wonderful, sir. You also see the need for special education. When do you think special educators may have to wind up their jobs and go, or you see them still lingering around, or you see them, you require them more now than before? What is your
We require more now
than before?
Another gap which we have, probably it's important to know that we also need another professional which is completely missing. We call them as assistive technology professionals. People who can actually evaluate assistive technologies, who can actually suggest assistive technologies to people, and maybe do the impact studies related to assistive technologies. So something which is called as assistive technology expert presently does not exist in countries such as this.
Ours, yeah.
So it may be wonderful to have, maybe, I don't know, we are still thinking a complete degree in assistive technology.
Okay.
Which may be a future, and I think country needs large number of such people. Even special educators, the number of special educators per capita which we have is one of the lowest in the world. So I think we need large number of special educators, mobility and orientation experts, as well as AT professionals as we go into future.
Do you find a place for robotics in that course, which you may launch in the future, assistive technology, a program in assistive technology?
True. Particularly countries such as Japan are using
robotics
for rehabilitation. And particularly assistive technologies for the elderly is another segment which we haven't discussed much. And I think that's where a lot of new applications of robotics is coming to help elderly is there. But I would say India still needs a lot of affordable technologies which can make quick impact. And I think robotics is still little far.
Okay.
But definitely it will happen one day.
Okay.
But we do need it.
Wonderful. So we are almost nearing and at the end of an hour. I can't help telling you the time passed by like 10 minutes. It's so wonderful talking to you. But let me summarize a little bit for the benefit of the listeners here. See, assistive technology is not necessarily an isolated field. It is quite integral to technology and thinking in technology. Second, it is interdisciplinary and multidisciplinary. And assistive technology is not necessarily just for learning. It is for human conditions that exist from cradle to grave. And assistive technology requires a larger attention, including across the spectrum, and we need assistive technology, special education, and much more than ever before. And people who work on disability and who may not work on disability will have to pay attention to assistive technology, because it is a sound and fundamental commentary on the technology world that we inhabit now. Thanks so much, Professor Rao, for wonderfully sharing your experiences and even more, much clearly for us. Thank you so much.
Thanks. I also thank you for this wonderful course which you are doing.
Thank you, Professor Rao.